So let's look at the units of the elasticity. The elasticity is a stress divided by a strain, or a force divided by an area, divided by a relative change in length. The strain is a relative change in length, so it's a length divided by a length. There are no units to that. The stress is a force divided by an area. A force divided by an area is a pressure. So the units of elasticity are pressure. However, we can understand this in a much more fundamental and intrinsic way. If we go to the molecular level, we see that the food is made up of all these separate molecules. And when we deform the food, whether we squeeze it or we stretch it or we deform it in any direction, what we're doing is we're changing the relative positions of the molecules. We're making the bonds between the molecules get larger or smaller. There's some energy for each of these bonds, and there's a certain number of bonds. And we can understand this. We can understand the intrinsic origin of the elasticity by remembering that the pressure is a force per unit area. But if I multiply the force by a length, and I multiply the area by a length, so I'm multiplying both the top and the bottom by a length, then a force times a length is an energy. That's like an energy of a bond. And an area times a length is a volume. That's 1 over volume is a density. So it's the energy of the bonds divided by their volume, or the energy density of the bonds. And that's a good way of understanding the physical origin of what the elasticity is. It's basically the amount of energy it takes to deform all the bonds. Because when you're changing the dimensions of the food, you have to deform all the bonds. As the number of bonds per unit volume goes up, the elasticity goes up. As the energy between the bonds goes up, the elasticity goes up. But the dominant cause of the elasticity is really the density of the bonds. The energy of the bonds doesn't change that much for different types of foods, for different types of materials. What changes is the density of the bonds. And that's why you can get very, very different elasticities, because the densities of the bonds change quite dramatically. So you can understand elasticity not as how you deform the food, but how you change the length of the bonds.